The question of when the Tesla Optimus robot will be ready for widespread commercial use is a key aspect of its development. The Optimus Gen 2 robot has demonstrated notable advancements in its capabilities, showcasing autonomous navigation, the ability to manipulate objects, and even interact with human workers within factory environments. These demonstrations indicate that the robot is progressing towards performing useful tasks in real-world settings. However, it has been observed that some of the more complex demonstrations have relied on teleoperation, where the robot is controlled remotely by a human operator. This reliance on remote control in certain scenarios suggests that achieving full unsupervised autonomy for a wide range of complex tasks in diverse environments remains an ongoing area of development. While significant progress has been made, the transition to a robot capable of fully autonomous operation across various situations presents considerable technical challenges. Recognizing the importance of public trust and regulatory compliance, Tesla has emphasized its commitment to safety, security, and privacy in the design and development of the Optimus robot. Given that humanoid robots are intended to operate in close proximity to humans, addressing potential safety concerns is paramount for ensuring their widespread acceptance and securing necessary regulatory approvals. Tesla's focus on incorporating safety features early in the development process reflects an understanding of the critical role these considerations will play in the successful commercialization of Optimus. According to the latest statements from Tesla, the company plans to initiate limited production of Optimus robots for internal use within its own manufacturing facilities, starting in 2025. Following this initial phase of internal deployment and testing, Tesla anticipates a broader commercial availability of Optimus to other companies by the year 2026. Interestingly, there have also been suggestions that Tesla might be considering offering consumer rental options for Optimus. This approach could serve as a strategic move to introduce the technology to a wider audience, allowing potential customers to experience the robot's capabilities firsthand before making a long-term purchase commitment. By lowering the initial barrier to entry, a rental program could facilitate broader adoption and generate valuable user feedback. Several key factors will ultimately determine the timeline and success of Optimus's commercialization. One of the most critical aspects is achieving a high level of full autonomy and reliability across a diverse range of tasks and operational environments. The robot must be able to perform its intended functions consistently and safely without constant human intervention. Another significant factor is the cost-effectiveness of production. Tesla has indicated a target price range of around $20,000 to $30,000 for Optimus, which is considerably lower than the current prices of many other humanoid robots. Achieving this price point through mass production will be essential for making Optimus accessible to a broad market. Furthermore, addressing ethical concerns and ensuring safe interaction between humans and robots will be crucial for public acceptance and regulatory approval. Finally, navigating the landscape of regulatory approvals and shaping positive public perception towards humanoid robots will play a significant role in the successful commercialization of Optimus. Tesla's strategy for the Optimus robot includes leveraging its capabilities within its own operations before broader commercial release. CEO Elon Musk has publicly stated that Tesla intends to begin using Optimus robots within its factories starting in 2025. Furthermore, video demonstrations released by Tesla have shown Optimus Gen 2 robots already performing practical tasks within a factory setting. These tasks include autonomously navigating around obstacles and human personnel, as well as handling specific components such as battery cells and loading sheet metal onto welding lines. The decision to initially deploy Optimus in Tesla's own factories provides a valuable opportunity for rigorous testing and refinement of the robot's capabilities in a familiar and controlled environment, allowing for the collection of crucial real-world performance data and feedback. The primary focus of Optimus's initial in-house use is expected to be on performing tasks that are considered repetitive, boring, or potentially dangerous for human workers. This includes activities such as material handling and assembly line work, which often involve repetitive motions and heavy lifting. Looking further ahead, there is even the potential for Optimus robots to eventually play a role in building other Optimus robots and even entire factories. The integration of humanoid robots like Optimus into Tesla's manufacturing processes holds the potential for significant broader implications. It could lead to increased efficiency in production, greater precision in manufacturing tasks, and an overall improvement in workplace safety by taking over hazardous roles. Furthermore, in a context of potential labor shortages, the deployment of robots could help maintain and even increase productivity levels. The successful implementation of Optimus in Tesla's factories could also serve as a model for other industries, potentially revolutionizing sectors beyond automotive manufacturing, such as marble processing and construction. Tesla has set ambitious targets for the production of its Optimus robot, reflecting the company's long-term vision for this technology. Tesla's internal plans for 2025 include the production of approximately 10,000 Optimus units, although CEO Elon Musk has indicated that achieving several thousand might be a more realistic outcome for this initial year. Musk has also mentioned an aim to have enough components available to assemble between 10,000 and 12,000 robots in 2025. However, given that Optimus is an entirely new product with novel components and manufacturing processes, a more conservative target of around 5,000 units for 2025 has also been suggested as a significant achievement. This range in production targets for the current year highlights the inherent uncertainties and challenges associated with scaling up the manufacturing of a complex new robotic system. Initial projections may be optimistic, and adjustments based on real-world production experience are to be expected. Looking ahead to 2026, Tesla has outlined plans for a substantial increase in production, aiming for a range of 50,000 to 100,000 Optimus robots. The long-term goal for Optimus production is even more ambitious, with Tesla envisioning a future where it can manufacture 100,000 units per month and eventually reach an annual production volume in the millions. While Tesla is gearing up for mass production, the current stock of Optimus robots is likely limited. The first Optimus robot was reportedly manufactured at the company's Fremont factory. Additionally, Elon Musk has indicated that Tesla anticipates having over 1,000 and potentially a few thousand Optimus robots working within its facilities throughout 2025. This suggests that the current inventory primarily consists of prototypes and early production units that will be used for internal testing, validation, and initial task deployment within Tesla's operations. Mass production for broader commercial availability is still in the early stages. To achieve its ambitious production targets, Tesla is implementing a phased approach to building its manufacturing capabilities for Optimus. The company is currently designing production lines with increasing capacity. The initial phase involves establishing lines capable of producing 1,000 units per month, followed by the development of more advanced lines with a capacity of 10,000 units per month. Looking further into the future, Tesla has plans for a third generation of production lines that would target an even higher output of 100,000 units per month. This strategic step-by-step approach to scaling production allows Tesla to learn and optimize its manufacturing processes at each stage, ensuring efficiency and quality as volumes increase. The development of the Tesla Optimus robot represents a significant undertaking with ambitious goals and timelines. The information gathered indicates substantial progress in the evolution of the Optimus robot, particularly with the introduction of the Gen 2 version, which showcases improved dexterity and mobility. Tesla has laid out a clear roadmap with targets for internal deployment in 2025 and broader commercial availability anticipated in 2026. The company's production plans are highly ambitious, aiming for a rapid scale-up from several thousand units in the near term to potentially millions annually in the future. Regarding the user's specific questions, the development roadmap includes the evolution from initial prototypes to the current Gen 2 Optimus, with a focus on achieving internal use in 2025 and commercial availability in 2026. Currently, Optimus is not ready for widespread commercial use outside of Tesla's own facilities, as the company is prioritizing internal testing and refinement during the low production phase in 2025. There is evidence of Optimus robots being used within Tesla facilities, performing tasks such as material handling and navigation in factory environments. As for production volume, Tesla is targeting the production of several thousand units in 2025, with a significant ramp-up planned for 2026, aiming for tens of thousands and eventually millions of robots annually. Notably, there is no specific information available regarding a Gen 3 Optimus robot in the provided material, suggesting that the current focus remains on the development and deployment of the existing generation. It is important to note some discrepancies and uncertainties within the reported information. Production targets and timelines have been adjusted over time, and there are variations in the specific numbers mentioned across different sources. Achieving full autonomy and commercial viability within the stated timeframes presents significant technical and logistical challenges. Expert opinions on the project have also been mixed, with some commending the progress, while others express skepticism about the feasibility of Tesla's ambitious goals and timelines. This skepticism often arises from the historical difficulties in developing truly capable and affordable humanoid robots. To overcome these doubts, Tesla will need to demonstrate consistent progress and real-world performance that aligns with its stated objectives. Recent updates, particularly from the first quarter of 2025, highlight Tesla's commitment to the Optimus project. The focus for this year is on initiating low-volume production for internal use, with a realistic goal of producing around 5,000 units. Plans for broader commercial availability in 2026 are contingent on the success of this initial phase and the continued advancement of the robot's capabilities. The Tesla Optimus robot project represents a bold and ambitious undertaking by a company known for pushing the boundaries of technology. While specific details about a Gen 3 robot are currently unavailable, the development of the Gen 2 Optimus has demonstrated significant progress towards creating a general-purpose humanoid robot. Roadmap and production targets. Tesla's roadmap includes an initial phase of internal use within its factories in 2025, followed by anticipated commercial availability to other companies in 2026. The production targets are aggressive, reflecting the company's long-term vision for the humanoid robot market. Overcoming challenges. Achieving these goals will depend on overcoming technical challenges, ensuring cost-effective manufacturing, and addressing safety and ethical considerations. Potential impact. The Optimus project has the potential to significantly impact various industries and even our daily lives. Continued development. And its continued development will be closely watched by the technology and robotics communities.